All right, so this is a crash course in organic chemistry, and I do mean a crash course. Okay, you love crash courses. There is another paper that we need. There is a crash course. I had another paper for you. I'll have to find it. Okay, so just to get another song stuck in your head, I've come up with a song that has to do with organic chemistry. What is organic chemistry? It's all around us. It's made up of carbons. Anything that compound that has carbon in it usually is considered organic. Okay, it's all about the living world around us, and it has carbons in it. So, yep. All right, so this is a song most of you know, okay, from, it's not politically correct, it's okay, but just to get that song in your head, 1 little, 2 little, 3 little Indians, 4 little, 5 little, 6 little Indians, 7 little, 8 little, 9 little Indians, 10 little Indian boys. Okay, we're going to put stuff to it that hopefully will help you remember organic, okay? It is simple, you can do it, you can name organic compounds. Learn this song, memorize it, then you're on your way. 1 ethane, 2 ethane, 3 propane, 4 butane, 5 pentane, 6 hexane, 7 heptane, 8 octane, 9 nonane, 10 is decane. Now you've got it. You can name organic chemicals if you know these 10. If there is a double bond, you change the ending to ene. If there is a triple bond, you change it to ine. Okay, so research has shown you got to do it at least something 3 times before it gets stuck in your head.
No. It's 7 times.
So we're going to go back and we're going to do this again. Ready? 1, 2, 3. It is simple, you can do it, you can name organic compounds. Learn this song, memorize it, then you're on your way. 1 methane, 2 ethane, 3 propane, 4 butane, 5 pentane, 6 hexane, 7 heptane, 8 octane, 9 nonane, 10 is decane. Now you've got it. You can name organic chemicals if you know these 10. If there is a double bond, you change the ending to ene. If there is a triple bond, change it to ine. I added that extra word because it fits better. Okay, compounds works, whatever. Ready? Here we go. 1, 2, 3. It is simple. You can do it. You can name organic compounds. Learn this song, memorize it, then you're on your way. 1 methane, 2 ethane, 3 propane, 4 butane, 5 pentane, 6 hexane, 7 heptane, 8 octane, 9 nonane, 10 is decane. Now you've got it. You can name organic compounds if you know these 10. If there is a double bond, change the ending to ene. If there is a triple bond, change it to ine. Okay, so those are the basic ones that you need to know. Methane, ethane, propane, butane, pentane, heptane, or hexane, heptane, octane, nonane, and decane. If you know those, you can basically name anything in organic compounds. When I've talked about, so this is what it means. That's how many carbons there are. Now you take that number and you times it by 2 and add 2 more, and you've got how many hydrogens? Okay? Times by 2 and add 2, and that's the ane ending. So an ane, carbon has 4 around it, 4 bonds it can make. Okay? So because it can have 4 bonds around it, that's why you times it by 2. That would give everyone 2, but the end ones need an extra one. So you have 1 for each end. And that's how you get the formula. Okay? Now, ene, we are taking one of those and making a double bond. So, because there's a double bond, we take away that +2. Because a double bond takes 1 hydrogen away from 2 carbons. Okay? Then we go to a triple bond, and a triple bond has -2 because it's taken now 4 hydrogens total away to make that triple bond. Okay? The more carbons, the more solid. So you go from methane, which is a gas, to octane, which is 8, which you put in your gasoline. Okay, that's a liquid. To wax at C42, or you know, 42. There's a lot of carbons there. So it's solid. So these ones, the whiny ones, tend to be whiny because one carbon is sharing 3, so think of your appendages as where carbon can bend. They're sharing 2, your arms, and 1 leg with somebody else. And so they're a little whiny because they have 1 foot to stand on. Okay? All right. Now, let's do some examples.
All right. Throw them at me.
Okay. So if I have CC, okay, this is what's known as a skeletal form. I have not shown the hydrogens. They are still there. I can do little tick marks to show them where they need to be. On the AP exam, they usually will throw them in there for you or ask you to do the Lewis dot for them.
Ethane.
This is ethane. Okay? Now, when they throw in other things, other compounds, and I don't know where I put those down, so let me see if I can remember real quick. Because I won't be here on Thursday, so we've got to talk about that too. I'm just going to do it up here. I've got to find them. I know I had them. I might have set them down at the back. When you have other things like this happen, okay, you can have what's known as isomers. So this is C2H6O. How else could I put it together? I could put it CCOH with H and H and H and H and H. So there's 2 isomers for this formula. So an isomer is just different ways to put together the molecular formula. Okay? So if I took C4H10 and I wanted to write all the isomers for it, I could do a straight line. That would be one isomer with 10 hydrogens.
Or you could do a box.
I couldn't do a box, but I could do this. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Is there any others I could do? That would be the same. If it was an L, it would be just a straight line. Because I can actually draw this one, the line diagram that you sometimes get in your medicines as you're going from the doctors or from the pharmacy. It would have written it like this. Or it would have written it like that. Okay, every point is a carbon. So that's a carbon, that's a carbon, that's a carbon, that's a carbon. Here, 1, 2, 3, 4. And we know that there's enough hydrogens to make 4 bonds around every carbon. Okay, now when I have something like this, this tends to help me be a polar molecule. Rather than putting it in here, this makes it nonpolar. Okay, because this oxygen has a greater electron density and therefore pulls electrons towards it because it has more pull on the electrons, has a more electronegative pull, and the mass there pulls the electrons. So this side becomes slightly negative and this side becomes slightly positive. So that is a polar molecule. Where with the oxygen in the middle, it's pulling both ways, and so there's no positive side, negative side because it's in the center. Okay? There's several different kinds of molecules. The big thing that you need to know with organic chemicals, and this goes back to Lewis dot, is that carbon has 4 dots all the way around it. What shape does it take when it bonds with stuff? Starts with a T. Tetrahedral. The shape that carbon bonds in is tetrahedral. Now, if I take that away and make a double bond, it bonds in a plane. Okay? So it actually look like this, and it's all flat in a plane. If I take and make it a triple bond, I'm now taking 3 that are sharing between, and I've actually made a line. So it straightens it out. When they are single bonds like this, it actually looks more like this because they bend to try and get the hydrogens as far away as possible from each other. So here's hydrogens up here, here's hydrogens down here, and here's my 3 hydrogens on the end. So they bend to get them as far away as possible. Okay? Because remember that tetrahedral shape. So it's not a perfect line, straight line. All right. We get to a blank page here so we can do, I actually want to go through this other one right here real quick.
Like dye and all that. Mono and stuff like that.
So
Like mono.
you'll need to be able to name, yes. I don't know why this is, there we go. So
H2O.
we have a lot of refineries by us down in Bountiful. We change, yeah, this isn't right here. This is somewhere else, but we do have a bunch of refineries, and basically what they're doing is they're taking long hydrocarbon chains and breaking them down. It's called fracking. Okay, they're breaking them down to smaller pieces. It depends on how it's done. Okay, we already talked about this. I'm going to go through the fast ones. Inorganic are compounds that don't contain carbon. So organic are compounds that do contain carbon. Carbon is unique because we have hybridized this. Now notice that it can be written this way. Usually the 2 is right in front. That should be a 2. That should be a 2. Sometimes they just drop the 2 and do that, so you know that. Okay, it has room for 4 bonds. Organic compounds have specific geometry. You need to know carbon does the tetrahedral thing. Okay, that's really important because if you don't know that and you're looking at a molecule and you're trying to decide if it's polar or not, and you don't realize that it's not a flat molecule, you've got some problems. Okay. We talked about the tetrahedral geometry. So this is the 109.5 angle, and that's why we get an unbranched tens that's like this. We sometimes write it like this, but we've got to think in our head it's like this middle one. Okay? There's a lot of writing on that page, but basically that's what I wanted on that one. Okay, I haven't had a chance to remake this one from somebody I stole it from. They call these that are single chains alkanes. If it has a double bond, it's an alkene. If it has a triple bond, it's an alkyne or alkyne. Okay, whichever helps you remember. Okay, whoops. So ethane, ethene, ethyne. Okay, that tells me how many hydrogens are combined. So, what? Diene. Diene, yep. It's not hard. How many double bonds do you have? 1, 2, okay.
Well, it's confusing.
Well, you don't need to know how to name organic compounds. You need to be able to look at them for AP and be able to say, okay, are they polar, are they nonpolar? How many unshared pair of electrons do I have here? What kind of geometry is going on? So it's not a matter of knowing the name of them, but you need to know what happens with the shape. Okay, so we have a straight chain. We also can have, for the same one, remember these are called isomers, and you will need to know isomer. Isomer just means I put things together in different ways. This ring down at the bottom is not an isomer of these two, and that they have you distinguish between what's an isomer and what's not. This one is not because it has 2 less hydrogens. Now, if these had a double bond in them, and that had a double bond in it, then they would all be isomers. Okay? It's by the number of carbons and the number of hydrogens have to be the same. So we're not going to worry about naming, but this would be an N. Anytime you say an N, that just means normal. That means a straight chain. This one right here, this is isobutane. You've probably heard of isopropyl alcohol. That just means the OH is coming off the middle, the same. Okay? Alkenes and alkynes do the same kind of thing. This one, ethylene gas is what uses to ripen fruit. It's a gas that's given off. Okay? Namings are similar, except you do ENE. YNE is the same. I want to go through a couple of these. So when you have cycloalkane or cycloalkene, alkene and anytime you have a cyclo that has a double bond in it, it's known as an aromatic hydrocarbon. Okay, usually benzene is the most benzene ring. Let's see if I've got a picture of it coming up. There we go. Actually, that's not a benzene ring. A benzene ring, we usually write like this. Okay, every other one's a double bond. Shortcut version, we do with a circle in the center. Yes, those are known as benzene rings. Okay, benzene rings are not polar. Okay, because they're evenly distributed. Okay, a cyclopropane, not very happy molecule. Don't use happy. Very stressed molecule. Okay, because it's really close. Think of that, those angles that it needs to be an isosceles triangle. What would it be? Equal 60 would be the angle. What does it want to be? 109.5. So this is stressed. What about this one? Is this one stressed or is this one okay? That one's stressed because it's 90. Okay, what about this one? Getting closer to my 109, so probably easier. This one's probably the less stressed. Okay, or the least stressed.
Wait, so you can't personify anything.
No. You can say it's stressed. As far as stress is a non-personified thing. Stress is applied to a system.
So if you do personify it,
They get very grouchy.
I
I know.
personify things from my perspective.
If you personify it in your head to help you remember, that's great. Just don't write it down personified.
No, that's just hard.
Okay? So here it shows you what a benzene ring looks like and what it looks like without. Now phenyl, polar or nonpolar? Polar, good. What about a toluene? It will pull a little bit because there's something different. Xylene, it's going to have a little bit of polar. Okay? Now, is it a lot polar compared to the phenol? No, it's not very polar. Okay? Not in the amount that would help in any way. Okay, so petroleum here,
Petroleum.
I'm not going to worry about that.
Petroleum.
Crude oil. Okay, let's go back here. Okay, so this is what I was telling you about the different kinds of fuels. So as we start with methane and we get heavier and heavier, we get to a liquid, we get to kerosene, and we get to oils, and then we get to waxes. Okay, so the more carbons, the heavier the chain, the more likely it'll go into a different thing.
So since diesel is down lower, that's why diesel freezes like after.
Right. It's heavier and it has a lower melting point. Or sorry, yeah, lower. Does that work? Yeah. Yeah. I had to think for a minute.
2,2,4 trimethylpentane.
Or isooctane. So octane can be a lot of different ways. It doesn't have to be the straight chain. It can be a lot of different things going on.
That looks great. Those H's are real close.
Okay, hydrocarbon derivatives. I don't know that I need to talk to you. Oh, halogens.
Halogens.
Halocarbons. Okay, tell me electronegativity on halocarbons. Right? Fluorine is the most electronegative. So if I have fluorine on there, wherever fluorine is, it's going to pull the electrons towards it. So my electron cloud is going to pull towards the fluorine. So that's going to be a slightly negative side. Now, if the fluorines are equally distributed, fluorine doesn't affect it. But if fluorine is on one side, it's going to affect it. That also happens with oxygen and nitrogen. Okay, where oxygen, nitrogen, same row as fluorine, right? They're close to fluorine. They'll also pull the electronegativity that way.
Similar to alcohol.
Yeah. Alcohol is just an OH, just a hydroxide group. Okay, they name them a little bit different. They drop the fluorine and go to fluoro, chloro, or bromo, and iodo.
Hypothetically. No.
No, we're not going to do hypothetical. So, chloroform, polar or nonpolar?
Polar because it's positive.
Polar, because you got that positive. You got to think again, it's going to make that tetrahedral shape. So the carbon's going to be in the center, hydrogen's going to be above it. The other three chlorines are going to be down below.
Yep.
So it is polar. Okay, carbon tet. Okay, what about the dichloro, difluoromethane?
That's non-polar because they're all just like.
Right, but fluorine is more electronegative.
Fluorine is more electronegative, so it will pull the electron cloud. It has a larger electron cloud, just barely, than chlorine, so it will tend to pull that electrons towards it. So you'll be slightly positive and negative on that side.
Polar.
Okay, what about vinyl chlorine or vinyl chloride? It's polar because we've got that chlorine that's off to the side, larger electron, polarizable cloud. That's the key words, okay? It'll pull the electron towards it, okay? You know PVC? They use this to...
Right, but I mean, like, why do they name it? Why is it vinyl?
Oh, I don't know why they named it vinyl. Just use it over and over again, so they had to come up with a
No,
simple
I mean,
way.
like, vinyl is what? In a compound.
A 2-carbon double bound part. So like PVC is polyvinyl chloride. So you've attached several 2-carbon chains that have a chlorine on it.
I got you.
Okay, so this one, alcohol, has a hydroxyl group. If you put a di in front or a tri, it just means how many hydroxide groups you have. Okay, methanol will change to formaldehyde in the system. They call it wood alcohol. Wood alcohol turns to formaldehyde. That's why it's a bad thing. So if you drink wood alcohol, they call it white lightning because that's what it attacks the optic nerve first, and then you're dead. So they see white lightning and then they die. Okay.
What happens during the Prohibition?
That's what happened during Prohibition. Yep. So there's methanol, ethanol, propanol. Now notice what's happening. Methanol and ethanol, I don't have to tell where the hydroxide is. But when I get to 1-propanol, I do because there's also a 2-propanol. So it depends on what carbon it's off of. Okay? And I always take the shortest route to name it. Okay, gasoline, we don't really need to go there.
Gasoline.
Whoops, back. Okay, so some common ethanol is drinking alcohol. Ethanediol is, I believe we call it, yeah, ethylene glycol. And glycerol is glycerin. So they make soap with that.
Nitroglycerin. Yep, doesn't it blow up?
Yep. Okay, so in ether, where's the oxygen?
In the middle.
In the middle, polar, nonpolar? Non. Aldehyde, double bound oxygen somewhere in at the terminal end of a carbon chain. So the very end of a carbon chain, polar or nonpolar?
Polar.
Polar. A ketone has it attached in the middle, a double bound oxygen in the middle, polar, nonpolar. Keyword middle. Okay, so carbonyl, which is a double bound oxygen. You got an aldehyde, a ketone. We name it methanal, formerly formaldehyde, and propanone for acetone. The ONE just means it's in the middle. Okay. So now we got acids and esters. So acids and esters, I'm going to go faster here. Okay. This is what I had to do formic acid. And I had to, in my organic class, actually draw a line that ants were supposed to follow so much time. And it took us 2 weeks to synthesize formic acid. So we had to do that, and if it followed this far, we got this grade. If we followed this far, we got this grade. If we followed this far, we got this grade.
What'd you get?
So it was very stressful. I don't even remember. I just remember the stress. Okay, so, okay, let me go back here because it didn't tell you what they were. So an acid will have a C double bound oxygen, COH, and it will be attached to a group coming this way. So, polar, nonpolar? Polar. And since it's an acid, it will lose that hydrogen. Not any of the other hydrogens, but the hydrogens that's attached to the oxygen. Okay? An ester has a carbon chain coming this way, has a carbon attached to a double bound oxygen, single bound oxygen, and then to another chain going that way.
Okay, well, so
And esters are smells. So if you smell chocolate, that's an ester. If you smell lemon, that's an ester. If you smell stinky, that's an ester.
if I smell
Okay?
bread,
If you smell bread,
so much sugar.
okay. They talked a little bit about PVC in some of them.
Metabolism.
Let's see, protein, structurally, functionally, we'll talk about. Oh, there we go.
Amino acids.
There are many amino acids. Now, look at them chemically. Now you're looking at them chemically, okay? Polar, nonpolar. This one's hard. This one is hard. This one has a little bit of a polar side, but you've got an OH. I think that's a CH2 on the bottom.
Yeah.
Okay. Polar, nonpolar.
Wait, which one?
This one.
Polar?
Polar, because we've got the COOH on the one side. So you need to be able to look at them and say, okay, this is going to be polar. This is where the electrons are going to be pulling. Okay? You need to be able to draw them. Okay, a lot of times they'll say, this is the basic structure, fill in the hydrogens. Carbon has 4 bonds around it. Nitrogen has 3. Oxygen has 2. And hydrogen has 1. Okay, so if you know those 4, you can fill in most everything.
CNOH.
Yep. Now, occasionally they do inorganics that you have to do the Lewis stop for. So there's just some others that we can look at. We're going to just go on here. Carbohydrates. They have put carbohydrates in there a couple times. Notice what's happening here. It's not an alcohol. It's a ketone sugar. So because it's a ketone sugar, we do have these OH molecules, but it's not a polar molecule. We've got too many OH. Okay?
Would it mess things up if you say like you alternate it so the O is on the bottom and the O is up here, and then would that change the compound?
That would change it would change how it reacts, yes. Okay, because that gives it a right or a left, and if you go on to 1120 or organic, you'll go more into that. So monosaccharide, disaccharide, we're not going to talk about a lot of those. Those are rings that have hydroxides up or down, depending on what's going on there.
Wait, cellulose.
Okay, so this is the rings I was talking about with the hydrogens up or down, hydroxides up or down, and how they bond back and forth. So depending on how they bond, this is a cellulose. That's a plant's carbohydrate, or whatever you want to call it. And this one is a starch that we would use. Okay?
Good old starch. So cellulose is like.
Okay, fats and oils are basically organic acids. Whoops, back. Okay, so they have an acid end that attaches to something. So this triglyceride you hear, your triglycerides are high because you've been eating too many fats.
Wait, so what's R1, R2, and R3?
That's just carbon chain.
Oh, that just means it continues on.
Yep, it continues on. Okay, I'm going really fast through this. I'm sorry. Polymers. They have talked about polymers. They have shown you things like this on the AP exam. Okay, the end just means this section repeats and repeats and repeats and repeats and repeats, and we don't know how many times it repeats. It just keeps repeating. Okay, so if they have you take one of these and make a polymer out of it, this one right here, this between these two carbons, is usually a double bond. So it's C double bond C before these are added, before it attaches to something else. So it has to be a double bond to start with, and then we bump them into each other, and the double bond breaks, and they attach. Okay? All right. And I think that's the last slide. Yep. Okay. Basic stuff with organic. Now, the test that you have next week with the ACS is going to have organic on it. Okay? You need to know basic organic. I do say basic. When I say basic, I mean you need to know methane, ethane, propane, butane. You need to know that ANE means single bond. You need to know ENE means I have a double bond. YNE means I have a triple bond. OL means I have an alcohol. Okay, AL means I have an aldehyde, which is a double bond oxygen on the end. Acid will be oic in acid.
Oic?
Because it's an organic acid. And organic acids are icky. So oic, that's how I remember it. Okay, you've got to remember ketone, double bound oxygen in the center. Aldehyde, double bound oxygen at the end. Ketone, and they end basically as they say. So ketone ends in ONE. Ester and ether. Ether reminds me of a bat where you have the oxygen in the middle. And an ester is like that, but it has a double bound oxygen next to the oxygen. Huh? A bat with a one eye, I don't know. Okay, so questions on that real quickly? No? Okay, we're headed back to lab to finish our Ka lab and our strong acid, strong base lab and get them finished and printed out. Which other lab? Oh, have we not done that one? Oh, okay, I guess we're doing that on Tuesday. We're going to have to do that Tuesday. Okay, let's finish the titrations. Remind me or I'll forget.